Batman's comments are quite distinct. Quite distinct. A well-known scientist, some say it was Bertrand Russell, once gave a public lecture on astronomy. He described how the Earth orbits around the Sun and how the Sun in turn orbits around the center of a vast collection of stars called our galaxy. At the end of the lecture, a little old lady at the back of the room got up and said, "What you've told us is rubbish. The world is really a flat plate supported on the back of a giant tortoise." The scientist gave a superior smile before replying, "What is the tortoise standing on?" "You're very clever, young man, very clever," said the old lady, "but it's turtles all the way down." Most people would find the picture of our universe as an infinite tower of tortoises rather ridiculous, but why do we think we know better? What do we know about the universe and how do we know it? Where did the universe come from and where is it going? Did the universe have a beginning, and if so, what happened before then? What is the nature of time? Will it ever come to an end? Can we go back in time? Recent breakthroughs in physics make possible in part by fantastic new technologies suggest answers to some of these long-standing questions. Someday these answers may seem as obvious to us as the Earth orbiting the Sun, or perhaps as ridiculous as a tower of tortoises. Only time, whatever they may be, will tell. As long ago as 340 BC, the Greek philosopher Aristotle, in his book On the Heavens, was able to put forward two good arguments for believing that the Earth was a round sphere rather than a flat plate. First, he realized that eclipses of the moon were caused by the Earth coming between the Sun and the moon. The Earth's shadow on the moon was always round, which would be true only if the Earth was spherical. We talked about this a little bit, actually, when we talked about these various models of the solar system. If the Earth had been a flat disk, the shadow would have been elongated and elliptical, unless the eclipse always occurred at a time when the Sun was directly under the center of the disk. Second, the Greeks knew from their travels that the North Star appeared lower in the sky when viewed in the south than it did in more northerly regions. Since the North Star lies over the North Pole, it appears to be directly above an observer at the North Pole, but to someone looking from the equator, it appears to lie just at the horizon. From the difference in the apparent position of the North Star in Egypt and Greece, Aristotle even quoted an estimate that the distance around the Earth was 400,000 stadia. It is not known exactly what length a stadium was, but it may have been about 200 yards, which would make Aristotle's estimate about twice the current accepted figure. The Greeks even had a third argument, that the Earth must be round. For why else does one first see the sails of a ship coming over the horizon? Why else does one first see the sails of a ship coming over the horizon, and only later see the hull? Oh, isn't that so cool? Thank you. Thank you, everybody, for being here. Thank you, Shavi. Thank you, Teeman. Thank you, John Foster. Thank you, Lazy Lad, who I think is Shavi. Thank you, Steven. Harper. Thank you, Eve. Steven, how could you be late? How? Just how? It just said hide, and I thought I did something with my mod power. Don't do that. Don't hide Steven. Steven's my friend who comes to the lives. Steven sneaks into room. We're talking about Brief History of Time. You might want to go back and watch the whole thing later. Thank you for liking. You know there's going to be a red moon this week. Really? Oh my gosh. Aristotle thought the Earth was stationary